since it contains E1, E2, E3, let us represent this as E4 and this as E5. So therefore E4 and E5 are called the loops. If there are more than one edges joining a pair of vertices, this edge is called as a multiple edge. A graph without loop and multiple edges is called a simple graph. So if it contains countable number of vertices and edges, then it is called a finite graph. If it contains infinite number of vertex and edges, then it is called an infinite graph. Hello dear students, welcome to this session of Discrete Mathematics class. I am Mr. Niranjan, Faculty, Department of Computer Science, Vidhyaashram, First Grade College, the Temple of Excellence. Today in this session, I am going to take very important concept that is called a graph theory. So very important concept is graph theory. This graph theory is very important for computer science students. Now let us know regarding what is the definition of a graph. Now what is a graph actually? A graph is a mathematical structure consisting of two sets V and E, where V is the vertex and E is the edges. So where V and E are non-empty sets. So a graph is a mathematical structure consisting of vertex and edges. So it can also be defined as a graph is a collection of points called vertices and the collection of edges is called a graph. That is, a graph is a collection of points called vertex and the collection of lines is called the edges, and therefore the collection of vertices and edges, that is called the collection of points and the lines. The collection of points as well as the lines is called the graph, which joins either in pairs or vertices of a single vertex. Now a graph is an ordered pair consisting of V and E, an ordered pair. So a graph is an ordered pair denoted as G is equal to V comma E, where V is a non-empty set consisting of vertex and E is a non-empty set consisting of edges. So a non-empty set consisting of vertex and edges is called G and it is denoted as V comma E. Therefore this is an ordered pair. So this is a mathematical structure. A mathematical structure consisting of V and E is called a graph. That's it. A mathematical structure consisting of V and E, where V is a non-empty set and E is also a non-empty set. V is called the vertex and E is called the edges. So the collection of points, vertex and the edges is called a graph. Now how? So where V is a non-empty set of vertices and E is also a non-empty set of edges. Now suppose if a vertex, if V contains, let us consider V is equal to V1, V2, V3, etc. Vm and E is equal to E1, E2, E3, etc. Em, then we are going to represent the graph as V comma E. Now let us take for example, let me write an example. Let us take a small example for a graph. So let us represent this as, this is the vertex, these are the vertex, and let us represent this as V1, V2, V3, V4, V5 and V6. These are the vertices and these are the edges E1, E2, E3, E4 and E5. So what do you say here? The collection of points is called the vertex. So these are the points 1, 2, 3, 4, 5, 6. 6 vertices are there. 6 vertex. And the collection of lines, how many lines? 1, 2, 3, 4, 5 lines. That is called the edges. That is equal to E1, E2, E3 are called the lines. So the collection of, that is V comma E, that is nothing but an ordered pair 6 comma 5. This is called a graph. This is a graph. So this is a simple example for a graph. So it contains vertex as well as the lines, and that is lines are called as the edges. Okay. So if a set V contains V1, V2, V3, etc. Vn, then E, E1, E2, En, etc. En, then the graph is denoted as V comma E, that is nothing but Vm comma Em. Now let us come to an example. In a ordered pair 1 comma 0 graph, how many edges are there? So here what is given? 1 comma 0. This is nothing but, according to the definition, a graph is nothing but V comma E. V comma E. So how many vertex are there? How many edges are there? So this graph contains only one vertex and the number of edges are 0. Suppose if a graph contains 2, 3, then how many vertex and how many edges? So this contains, how many vertex are there? There are 3 vertex, and how many edges? There are 3 edges. So 2 vertex and 3 edges. So this is how we are going to represent a graph using the vertex and the edges. Let us take one more simple example for a graph. So a simple graph. So suppose if there are 4 points, these are the 4 points, then this is 1, 2, 3, 4. Now join this. This is also an example for a graph. So the vertices are V1, V2, V3 and V4. So the edges are E1, E2, E3 and E4. So this graph contains how many vertex? 4 vertex and 4 edges. So that is equal to V comma E. Right. This is also example for a simple graph. So suppose if a graph contains m number of vertices and n number of edges is denoted as Vm comma En. So let us consider another example. Suppose if a set V contains the vertices A, B, C, D, E are the vertices and the edges are represented like this. E is equal to E1, E2, E3, E4, E5. Now to draw the graph for this, let us draw the graph of this. So this contains 5 vertices. So that is, let us write like this: A, B, this is B, C, D, E and F. Okay. So here, what are the edges? The edges are E1, E2, E3, E4 and E5. That's it. This is how we are going to draw a graph for this. So this contains how many vertices? So this contains 1, 2, 3, 4, 5 vertices. 1, 2, 3, 4, 5 edges. 5 comma 5. That's it. Okay. Now let us come to few definitions in graph. Now let us come to the first one, loop. What is a loop? This is very, very important. An edge joining a vertex itself is called as a loop. Edge joining a vertex itself is called as a loop. Now listen, let us consider, for example, let us draw a graph. This is a graph. This is V1, V2, V3. The edges are E1, E2 and E3. Now this is called the loop. This is called a loop. That means an edge joining a vertex itself is called a loop. An edge joining the vertex itself is called a loop. Another example, this is also an example for a loop. So therefore these two are the loops. Okay. Now since it contains E1, E2, E3, let us represent this as E4 and this as E5. So therefore E4 and E5 are called the loops. Now let us consider one more example for a loop. Let us write a graph. So suppose if this is a graph, V1, V2, V3, V4 are the vertices, and then if I draw a loop, this is let us represent this as E1, E2, E3 and E4. This is E5. If I write one more loop here, this is E5 and E6. So E5 and E6 are again example for a loop. So that means an edge joining the vertex itself is called as a loop. Now in general, an edge joining the vertex itself is called a loop. It's called a loop. These are all an example for loops. Okay. Now let us come to the next definition. Multiple edges or parallel edges. Multiple edges or parallel edges means if there are more than one edge. Multiple means more than one. If there are more than one edges joining a pair of vertices, this edge is called as a multiple edge. So that is, or it is also called as parallel edge. That is, if there are more than one edge joining a pair of vertices, then such an edges are called as a parallel edges, or they are also called as a multiple edges. Right. Now let us take an example. Let me draw a graph. So this is V1, V2, V3, V4 and V5. So the edges are E1, E2, E3, E4 and E5 are the edges. Right. Now if I join any two vertices, so let me join these two, that is by E6, this is E6, and again join these two, that is E7. So that means here these are called as multiple edges. So that is multiple edges. So E1 and E6 are the multiple edges which joins the vertices V1 and V2. Similarly, E4 and E7 are the multiple edges which joins the vertices V4 and V5. Okay, that means here the vertex V1 and V2, here the vertex V1 and V2 is connected by V1 and V2 is connected by the edges E1 and E6, E1 and E6. Similarly, the vertex V4 and V5 are connected by the edges E4 and E7. E4 and E7. So therefore, these are called as multiple edges, or they are also called as the parallel edges. Okay, that means you got an idea. Multiple edges or parallel edges means if there are more than one edges joining a pair of vertices, this edge is called a multiple edge. So here these two vertices are joined by E1 and E6. So therefore, here V1 and V2 are connected by the vertices, V1 and V2 are connected by the edges E1 and E6 is an example for a multiple edge. Or here also V5 and V4 is connected by E4 and E7. Therefore, this is also an example for a multiple edge, or they are also called as a parallel edges. Parallel, E1 and E2 are parallel edges, E7 and V4 also parallel edges. Just they are parallel. That is the meaning of parallel or multiple edges. Now, simple graph, the word itself indicates it's a simple. A graph without loop and multiple edges is called as a simple graph. A graph without any loop and multiple edges. A graph without loop and multiple edges is called a simple graph. Let me write this is an example for a simple graph. Here the vertices are V1, V2 and V3. The edges are E1, E2 and E3. This is an example for a simple graph. One more example, this is also an example, V1, V2, V3 and V4. This is E1, E2, E3 and E4. This is also an example for a simple graph. A graph without any loop, and multiple edges is called a simple graph. This is an example for a simple graph. Okay. Now let us come to the next one is multiple graph. What is multiple graph? Multiple graph means a graph in which no loops are allowed but more than one edge can be joined. Two vertices called is multiple graph. So a graph in which more than one edge can join two vertices. A graph in which more than one edge can join the two vertices is called a multiple graph, but no loop is allowed in this. Okay. How to define a multiple graph? A graph in which no loops are allowed but more than one edge can be joined two vertices is called as a multiple graph. So it can also be defined as a graph which does not contain any self loop but it contains multiple edges. A graph which contains multiple edges but not contains self loop is nothing but a multiple graph. Now let us write that graph for this. Let us write one. Let me take one small example for this. Let us write a graph of multiple graph. Now let us write a multiple graph. So let me write. This is an example for a multiple graph. So a graph which has no loop but more than one edges can join two vertices. So let us write this as V1, V2, V3 and V4. The edges are, here it is E1, E2, E3, E4 and E5. This is an example for a multiple graph. Okay. Let us take one more example. So this is V1, V2, V3, V4, V5. The edges are E1, E2, E3, E4 and E5. So let us write another edge, that is E5, E6. Let us take one more edge here, that is E7. This is also an example for a multiple graph. That means a graph which does not contain self loop but contains multiple edges. It contains multiple edges is called as a multiple graph. Let us come to the next definition, pseudograph. Pseudo means a graph which contains both multiple edges and loops are called as the pseudograph. So, a graph which contains both multiple edges and also loops. It contains multiple edges and the loops are called as the pseudograph. Multiple edges and multiple loops are called as a pseudograph. Now, let us draw a simple example for this. Let us draw a simple graph for a pseudograph which contains both multiple edges as well as the multiple loops. Now, this is an example. Let us write V1, V2, V3, V4. The edges are E1, E2, E3, E4, okay, and another one V4, this is V5, the edges are E5 and E6, this is E6, and which contains multiple edges and loops also. Let us write a loop here, this is E7 and here it is E8. So, this is an example for a pseudograph. So, here it contains, which contains multiple edges as well as the loops. This is an example for a pseudograph, okay. So, a graph containing a self loop as well as the multiple edge is called as a pseudograph. That's it. Let us come to the next concept, finite graph and infinite graph. So, finite means number of vertices and edges are finite. So, if it contains countable number of vertices and edges, then it is called a finite graph. If it contains infinite number of vertex and edges, then it is called an infinite graph. So, a graph which contains finite number of vertices as well as edges is called a finite graph. So, a graph which contains finite number of vertices as well as edges is called a finite graph. On the other hand, if a graph which contains infinite number of vertices and the edges, then it is called as an infinite graph. So, if a graph contains finite number of vertex and edges, then it is called a finite graph. If it contains infinite number of vertices and edges, then it is called as an infinite graph. Now, let us take an example. Let me draw a graph for a finite as well as infinite edges. Now, let us consider this example. So, this is V1, vertex 1, V2, V3 and V4. The edges are E1, E2 and E3. So, this is an example for a finite graph. This contains 4 vertex 1, 2, 3, 4, V1, V2, V3, V4 vertex and 3 edges. So, this is nothing but 4, 3. So, here the number of vertex and edges are finite. Therefore, this is an example for a finite graph. Okay. Or one more example, I can write like this. V1, V2, V3, V4 and another line, take another line. This is V5. So, here E1, E2, E3, E4 as well as E5. So, this is an example for a finite graph. So, this contains 5 vertex and 5 edges. Now, whereas an infinite graph means a graph which contains infinite number of vertex and edges. Let us take an example. If I write like this, here it contains vertex V1, V2, V3, V4 etc. and the edges. This is an example for an infinite graph. Let us write one more example for infinite graph. So, these are all examples for a infinite graph. That's it. Okay. Since it contains infinite number of vertices, infinite number of vertices and infinite number of edges. So that is E1, E2, E3, etc. Here also V1, V2, V3, E1, E2, E3, etc. Infinite number of vertex and edges. Then this is an example for a infinite graph. So in general, a graph which contains finite number of vertices and edges is called a finite graph, whereas a graph which contains infinite number of vertex and edges is called as an infinite vertex. So in general, a graph is nothing but a collection of mathematical set collection consisting of vertex and edges is called as a graph. These are few concepts regarding the definition and the types of graphs. So that's all regarding today's session. Let us meet with a different concept in the next session. Thank you very much.